Hello, so in today's video, we're going to look at algebraic long division. So we're just going to look at one example today. So this example here, so 2x cubed take away 6x squared plus 5x minus 4 divided by x minus 2. So this is kind of a continuation from yesterday's video where we looked at the factor theorem, where we realized that if we could find a number that we could substitute into a function that gave us 0, then we could tell from that that x minus a was a factor of f of x. So we can also, to determine factors, we could also do some long division as well, but that's normally going to give us remainders, as we'll see in this video today. But before we actually do this calculation here, we're going to just look at a brief basic example of dividing an integer 1, 2, 3, 4 by 56. So this is like, I guess, primary school maths, I guess. So we've got 1,234 divided by 56, and we're going to use long division. I mean, we could use the bus stop method where we just put the numbers up there, but we're just going to do it using the long written out division like this, as we'll see in a minute. So yeah, so first of all, how many 56 is going to 1? Well, that's none. How many 56 is going to 12? That's none. How many 56 is going to 1, 2, 3? Well, if you think about the 56 times, say we've got 56, the next number would be 112. Okay, so what we're going to do is write 112 down there. I mean, as I said, we could just write the two up there and do the quick method, but I'm going to do the long method because that's going to be helpful with the algebraic division. So yeah, so 2 times 56 gives us 112, and then what we're going to do is just subtract, obviously write the 2 up there. 2 times 56 gives us the 112 again. So we write the 112 there, and then we subtract the first 3 digits that we see by the 112, and then we're going to bring the 4 down there. So yeah, 123 subtract 112 should give us 11. So we get 11 there. So we got 114. And then we're going to say, okay, so how many 56 is going to 114? Well, that's going to be 2. And then what will our remainder be? Well, do 2 times 56. So again, we're going to subtract 112, and we're going to be left with 2. And then how many 56 is going to 2? Well, that's none. So we get a remainder of 2. So our final answer, 1,234 divided by 56, is going to be 22, remainder 2. But what does that mean? Well, that just means 22 and 2/56. So 2 over 56. And that's just exactly the same as 22 and 1 over 28. Okay, so that's just a brief example of how we do long division. So that's going to be kind of, it kind of links into what we do here. So again, we're going to do like a bus stop method with this algebraic example. So x minus 2 there, have your bus stop there, 2x cubed minus 6x squared plus 5x minus 4. So then what we're going to say is we're going to look at the x number there, or the term there, and we're going to say how many x's go into this first term there. So how many x's go into 2x cubed? Well, that's going to be 2x squared, sorry, 2x squared, because 2x squared times by x gives you 2x cubed. Okay, so now what you're going to do is you're going to times this by that, similarly to what we did back here. So we would times the 2 there by the 56 to get this 112 there. So we do the similar thing here. We times the 2x squared by the divider. So what we're going to do is subtract the product of 2x squared with x minus 2. So that's 2x cubed minus 4x squared, because 2x squared times 2 gives you 4x squared. Obviously got the minus sign there as well. So we're subtracting that. And then we do the same thing. We're going to bring that 5x and that minus 4 down there. And then we do 2x cubed minus 2x cubed. Well, that's just 0. Minus 6x squared minus 4x squared. That's going to be minus 6x squared plus 4x squared. So minus 2x squared, like that. Okay, and then the method continues. So now the next step, how many x's, so again, we look at just the x variable, how many x's go into negative 2x squared? Well, that's going to be negative 2x, because again, negative 2x times by x gives you negative 2x squared. And then again, the same process, we're going to do negative 2x multiplied by our divider or divisor, and that's going to give us, so yeah, negative 2x times x again is a negative, so negative x 2x squared, and then negative 2x times by negative 2 is positive 4x, so positive 4x in there. I'm just going to make the writing smaller. Okay, so now then we're going to subtract these, so we get, again, bring this minus 4 down there, so we're going to get negative 2x squared, negative 2x squared, so the 2x squares go away, and then 5x subtract 4x will just give us x. Okay, so we're left with x minus 4. Okay, so then the question becomes how many x's, so again we look at the x there, how many x's go into x there? Well, that's just going to be 1, positive 1. And then we do the same calculation. So 1, the number we get there, multiplied by a divisor. So 1 times x minus 2. So we're going to subtract literally x minus 2 at the end there. So when we do that, x minus x is just 0. Minus 4 minus minus 2, well, that's minus 4 plus 2. So that's going to give us minus 2. So we get a remainder minus 2. Okay, so what does that mean? So it means that when we do this calculation, what we get is the following. So we get a final answer, 2x cubed minus 6x squared plus 5x minus 4 divided by x minus 4 is equal to 2x squared minus 2x plus 1 with a remainder of minus 2. And again, what does that mean? Well, in this context, it means 2x squared minus 2x plus 1 minus 2 over the divisor, which is x minus 2. So similarly to what we do here, the remainder 2 is over the divisor, 56 in this case. So we get 2 over 56. Similarly here, the remainder is minus 2 over the divisor x minus 2. So we get this here. So therefore, that would be our final answer. So when we divide this number by this number, when we divide that number up there by this number there, we get this number here. So we get 2x squared minus 2x plus 1, and then minus 2 over x minus 2. So this can be, this is quite useful, for example, when we do in future videos, partial fractions, it can be useful for. And it can be also useful for solving equations and applying what we did with the factor theorem in the previous video. Yeah, this long division can be useful at times.